Up to now, most of the programming we've been doing in MATLAB has involved simple step-by-step running in a sense. MATLAB just reads the script line by line and conducts the commands as it comes across it. For example, a piece of code will define variables, perform calculations, and then plot results. But decision making is an important part of programming and allows certain commands to run depending on certain conditions. And this part of this lecture, this video, covers what's known as conditional programming, which can alter the flow of a program and skipping commands depending on whether certain conditions are met or not. Now, in the notes on page 62, there's a little table that identifies the characters that you need to enter, whether you want to check something equals something, whether it's not equal, greater than or equal to, less than or less than and equal to. And these are the symbols, or the series of symbols that you need to enter into MATLAB. You can combine conditions using the and or not operators, and that follows standard logic. And when MATLAB checks for conditions, it returns a value, either 1, which is true, or false, which is denoted by 0. And what we can do is we can test some of these things. So there's an example that we're going to run through. So if I say A equals 10, and we've got B equals 15, and C, which we're going to make equal to 12. Okay. Now, like I said, we can actually check for conditions. So if we say A less than B, and what MATLAB will do with the operators is going to check to see whether A is less than B, and if it is less than B, it should return a 1, and if it is not less than B, it will return a 0. So A is less than B, logical, it says 1. Okay. And then if we do A is greater than B, okay, again it's going to check it and it will come back with a 0. And you can combine these things. So if we say C is greater than A plus B, again it's going to check that C is greater than A plus B, and that should return a 0. And likewise we can combine them. So C is greater than A and C is less than B. Okay, so it's going to check that C is greater than A and C is less than B, and if that's true, that will come back with a 1. Okay. So those lines in the notes, they're 4, 7, 10, and 13, but these are the things I've actually entered. This line, this line, this line, and this line. Okay, they're known as logical expressions, and the results can only be either true or false, either 1 or 0, respectively. Now you can do similar things with vectors, okay, to compare the elements, element by element. So if we try the following, x equals 1, 5, 3, and 7, and we've got y equaling 0 to 8, 8, and 7. Okay, so we've got our two vectors x and y. And if we say k equals x, y, so x is less than y, okay, what it's going to do is come up with a vector which is a logical array, okay, and that shows you that where x is less than y, it will give you us a 1, but where x is greater than y, it will give us a 0. So you can see that 0 is less than 1, so that's a 0 here. 2 is less than 5, so that's a 0 here. But 8 is greater than 3, so there's a 1. And 7 is equal to 7, so obviously that's a 0 because it's not less than 7 or greater than 7. So if we say k equals x is less than or equal to y, okay, this time we'll get another logical array, and this time that last one, because 7 is equal to 7, we get a 1 there, so we've met that requirement. And likewise we could keep going. 7 is greater than y, x is greater than y. Then we get another logical array where these two numbers, 1 and 5, are greater than 0 and 2 respectively, and the last two elements don't work. We could run the same command, but we have equals to in there. We get the 1 for the last column. We could say k equals x, y, so that's basically saying where do they equal, so you should get 1 in the last thing. And we could also say k equals x. Sorry, k equals x. And then we use the tilde character equals y, and that's where they're not equal to each other. So we get 1, 1, and 1. And notice the difference between the symbol used to assign a variable, which is 1 equals sign, and the symbol used to check equality, which is 2 equals sign. And if we wanted to combine it with logical operators, okay, so let's go for k equals, so x is greater than y, and x is greater than 4, okay. So if we go with that, you can see that the only combination of variables in here is this middle one in the middle. Okay, x is greater than y, okay, because 5 is greater than 2, and x is greater than 4, because obviously that's the only one where x is greater than 4 and 5 is greater than 2. Okay, we could do another one. K equals x is greater than y, or, so which is the straight arrow character, x is greater than 4. So that will give us the 1, 1, and 1, okay, where basically x is greater than y in this case, and in this case it's also greater than 4, so it gives us a yes for those things as well. And if we want to go for not, we can say k equals, so tilde, x is greater than y, okay, or x is greater than 4, okay, and that will repeat the command above here, okay, this one here, but it'll only give us a 1 when that's not the case, not true. So we get the opposite of this logic array here. We get the 0, 0, 1, 0. You can see that when we're comparing two vectors, the result is a logical vector. A logical array is basically a vector because it's a single row. Okay, and these logical things have different icons in the workspace. So you can see that up here, you can see K has got an icon with a tick, because that's basically checking yes or no. Okay. And relational logical operators can also be used to modify variables. This is best explained via an example here. So we've got m equaling 2, 4, 6, and a new line 8, 6, and 4. Okay, so there's our matrix M. And if we want to set all elements with a value less than 5 to 0, we say m, and then we say m less than 5 equal 0. Okay, so now it's going to take any values that are less than 5 in this vector and set them equal to 0. So then we have 0, 0, 6, 8, 6, and 0. So, and you might think of this as m, where m is less than 5 becomes 0. Okay. And if we want to negate all values greater than 7, okay, we could say m, where m is greater than 7. And we want to negate them, so we're going to write minus m, where m is greater than 7. Okay, so that'll turn all values greater than 7 into negative.